Keysight テクノロジーの
So this is Kikuchi from Keysight Technologies. Thank you for giving me this opportunity to speak to you today. At Keysight, quantum bit design solutions. We provide these solutions to our customers. So I want to talk about the latest features for these solutions. To start with, I would like to introduce our company. In 1939, we started as part of Hewlett-Packard. And in 1999, from Hewlett-Packard, we span out as Agilent Technologies to become the electronic measurement company. And 14 years back, the electronic measurement division of the Agilent Technologies became independent as Keysight Technologies, focusing on electronic measurement. From the beginning of establishing Hewlett-Packard for about 80 years, we have been involving. We are the innovation leader in terms of measurement equipment and software. In 2016, since about 8 years ago, we have QES, Quantum Engineering Solutions Department, to start the development of quantum solutions in a full-fledged manner. We have top-ranking quantum researchers, engineers, professors. These are the members of our team dedicating to quantum engineering. And as you can see, hardware to measurement automation and quantum error suppression, 3 companies we acquired to expand our solution portfolio. In addition to that, since we are an electronic measurement company, we have electronics, design softwares. We can combine them together so that we can apply them to quantum applications such as quantum computing, quantum communications, as well as quantum sensing. And we are providing these solutions to the market. From this slide onward, I'd like to focus on the topics of this presentation. Out of the quantum application solutions, we have quantum EDA solution and quantum bit control solution. I want to talk about these 2 latest features. Starting with EDA solutions for superconductive quantum computers, Quantum Pro. At Q2B last year, we talked about Quantum Pro. We just made the announcement. It was immediately after our announcement, so we introduced this product and covered basic features. This Quantum Pro, quantum nonlinear analysis is possible. So this integrated high frequency development environment, ADS. And we have 5 functions, as you can see on the slide. A layout library, for example, it's available in this product. For quantum circuit, quantum artwork is often utilized, so we provide that as library so that you'll be able to design the quantum circuit from the scratch. And electronic magnetic analysis is easily done with this product when you have more qubits. Electronic field or electromagnetic field analysis is very complex, but this is made intuitive so that you can carry out the electromagnetic analysis easily. For analysis method, we provide finite element method as well as moment method. By providing these methods, fast simulation is possible, making the design cycle shorter. When you have electronic magnetic analysis, you get a frequency response from the circuit, so you'll be able to extract quantum parameters automatically, like quantum bits. And other useful features for design would be nonlinear circuit and also EM circuit co-simulation features that are also available in this product. So I want to talk about the latest features of this Quantum Pro. First of all, as you can see, I want to talk about the multi-layer design support. There are multiple quantum bits, chips, setups. As you can see, we have substrate stack-up as well as layout library. You can combine them together to create multi-layer chip layout for EM analysis. IBM's Eagle, it's not created based on this, but this is a 3-layer layout as an example. As you can see, this is made of multiple qubits and chips, and analysis of this type of quantum is possible. Next, I want to talk about layout library for JTWPA artwork. From the latest software version, JTWPA artwork, this bent structure, as you can see, is now supported. Other layout structures, as soon as we get requests from users, we are ready to provide and add more structures. As you can see, this is a complex devices with Josephson conjunction. By having this electromagnetic analysis, you can also analyze nonlinear analysis. This is one example here, as you can see on the right-hand side. This is MIT's photograph. JTWPA analysis and design are available on top of this product. Thirdly, we added a noise model for quantum application. Especially quantum circuit bits, we do use microwaves, cables and connectors for microwaves. These component models are required. Utilizing that model, you can explore different systems. And what becomes important is noise analysis. And utilizing this noise model, you will apply this to your analysis. The right-hand side of the slide indicates a quantum system noise analysis. This is part of the paper, how it's set up and the result of the analysis. Red area indicated here is the circuits of Quantum Pro that is actually deployed there right in the center. And the left, you see the result of the analysis. The paper result and Quantum Pro result, if you compare them together, you see how these results are close to each other. Fourthly, a new feature that I want to talk about is the addition of quantum devices. Parametric quantum circuits, Josephson conjunction model is added. Magnetic loop is reproduced. As you can see, this is a loop simulation that is available, such as snail, snake, squids. For these circuits, we can apply this magnetic loop for your simulation. And as you can see, utilizing this new feature, this is 5-stage snake example. And you see upper right-hand side, this is DC-DC squid. This analyzes phase and electric current. By adding this quantum device, what was not possible is now possible. So far, I talked about quantum bits, quantum parametric amplifier design, and how Quantum Pro new features can be applied to that. And now I want to talk about the quantum bit control system and its new features. We have large-scale quantum system. QCS for that has been launched for about 2 years, and this is a hardware. Maybe this one is easier to understand. We have software stack and hardware combined together. And features include, as you can see on the right-hand side, it has high performance, fully digital. It has high scalability. And in terms of performance, semiconducting a quantum bit require or input or output pulse 16 gigahertz from DC. It's a very high, wide frequency range. Throughout this frequency, with a wide range of pulse can be output. And down converter receiving the output over 2 gigahertz, we have a wide range of width. So throughout the system, over 2 gigahertz width. And reference clock source, we have very high performance clock embedded inside. Because of that, industry's best possible phase noise system. And as I said, control pulse and wave generator, 5 gigahertz to 10 gigahertz microwave is utilized, and analog mixer is not utilized here. DA converted output is directly output as microwave. It's completely digital technology that is introduced. As a result, temperature drift that is seen in analog device is minimized. And in terms of LO down converter, we have applied same technologies so that the signals will be generated digitally. And in terms of scalability, the third point, we have down converter, digitizer. Major components are modularized. If you increase the number of qubits to control, you can increase the number of modules and number of chassis and number of racks can also be increased. Internally, AIST 1000 qubit system, they ordered this system, and currently we are making preparations for shipment. 2 years ago, we released the hardware, and after that, firmware and software, we are upgrading these with new features. There are multiple new features today. Because of the time constraints, I just want to talk about 3 features: through Q integration, graphical workflow, and remote job submission, as well as cloud support. So I just want to talk about these 3 features, starting with through Q integration. This is error suppression function. This morning, the Fujitsu speaker talked about error suppression. They mentioned our company's name, so it is utilized for Fujitsu. This is 2Q software. Target quantum circuits are there, and we have randomized compiling and noiseless output extrapolation and readout calibration. Post-processing is done by the computer so that we'll be able to reduce the quantum error. QCS hardware and software, we had a separate product from those hardware and software, but this latest QC2QC software, now this is integrated. The benchmarking of 2Q and also error mitigation protocol are all integrated. As a result, QCS hardware, if you use hardware, you can control quantum bits. And when you do this, you can apply this through Q so that you can achieve a quantum error mitigation. This is a classical workflow that is also graphical workflow that is added. In measuring quantum bit, Python script is often utilized when you write a code. But as you can see, this is low code environment. It's hard to see. If you connect the measurement widget, you will be able to measure the flow, quantum flow. After the measurement is done, as you can see on the left-hand side, you can open the measurement widget for analysis. And this is the amplifier spectroscopy. And as you can see, the data is visualized. So in what way this is going to work, I'd like to show you this video. Each one of these circles is the widget to measure or plotting widget. From left to right, the measurement flows and moves. In this case, we have spectroscopy to T1. You see the order is indicated, and the left-hand side, if you click on that circle, flow will start to operate. The measurement, once it's done, if there is data, plot widget, you can click on this to open this screen. Spectroscopy, for example, you can apply fitting multiple windows can be displayed for your data comparison. And this is IQ or amplitude phase. What type of data you want to render or show, you can dynamically switch. This is IQ. This is quantum bit measurement flow. You can build this flow easily. And so this is the new development added to the product. And thirdly, remote job submission and cloud support. Chassis control hardware, or the PC that control hardware, and there was a problem of making measurement on top of the hardware. But since May, from remote PC using network, you'll be able to submit jobs. From the next version onward, you will be able to divide hardware into the measurement units. And this will be the new feature being added. And multiple users, they will be able to execute jobs concurrently. For example, 2 users in this case submitting jobs to one single measurement equipment. Of course, you can divide them into chassis unit. So multiple users will be able to access to the same hardware. Succeeding job will be placed in a queue. It has to wait for the preceding jobs to be completed. On top, you see, this is the execution that takes place in an enterprise. But the lower one is the case that is connected to the cloud. So from external network, users will be able to connect or access cloud. QCS hardware can be utilized as quantum computer. So if you want to use cloud, you will be able to upload data externally on cloud. And cloud dashboard is provided. As you can see, when user logs in, you will see this screen pop up. Of course, the design of the screen will be customized. The recent jobs that are executed, for example, are displayed. There are 2 ways to execute jobs on cloud. First of all, the third one from the top, lab. If you click on lab, Jupyter Lab will open up. There is a tab over there, and you can write Python code for execution. That's one way of executing jobs. Or you could go to local PC, you can write the Python script. And there's API key there. You can use that key to connect to a cloud to execute jobs. So that's all from myself. The superconducting quantum bit, software, control software, and design software. I focus my talk on these 3 things. We are an electronic measurement company, so other than these products, network analyzer for network analysis, oscilloscope for high bandwidth, and QCS that exceeds 2 giga bandwidth, and semiconductor parametric analyzer. Other than superconducting quantum bits, we have many different kinds of analyzers available. We do not have sufficient time till the end of Q2B event, but we have still our booth open, so I am hoping that you would visit our exhibition booth. This concludes my presentation. Thank you for your listening.